The average atomic mass that we see on the periodic table, for example right here for carbon, is calculated based on the weighted average of the naturally occurring isotopes and their percent abundance. Web Elements, which we're looking at right here, is a website that's pretty useful. It has all of the isotopic abundance information that you need on its website, as well as a whole bunch of other stuff. So we're going to go through an example of looking at calculating the atomic mass of an element. We're going to look at an example calculation, and we're going to pick an element to do the calculation for. So let's go ahead and look at silver. If you want to find the isotopic information for an element, simply click on the element and then scroll down. There's a whole bunch of stuff, physical properties, etc. And then if you get a little further down, you will see silver isotopes. And we will want to click on More Isotope and NMR Data. So this shows right here the naturally occurring isotopes. These are stable isotopes. If you're interested in radioactive isotopes, then just scroll down a little bit more and it will show you information about the radioactive isotopes. We're going to focus on the stable isotopes for today. So I want you to notice that we have two stable isotopes, silver 107 and silver 109. Their masses are listed right here, and those masses are listed in Dalton units, which is the same thing as atomic mass units, which is equivalent to grams per mole. You can see over here the natural abundances. The last number in parentheses, this is the uncertainty, and it would be in the last certain digit. So we'll go through that as a more specific example later on. And then you don't need to worry about the nuclear spin and the magnetic moment for right now. So we're going to switch back over to where I can write. And we'll go ahead and track this information. So the periodic table said that for silver, the average mass was 107.87 atomic mass units. So let's go ahead and see if we can calculate that. So the stable isotopes were silver 107. And just as a reminder, this number right here, this is the mass number, which is the number of protons and neutrons. So the mass of the silver 107 isotope was 106.905092, with 6 as the uncertainty in that place. And the percent abundance was 51.839 with an uncertainty of plus or minus 7 in this decimal place. The silver 109 isotope, which is the other stable isotope, has a mass of 108.904756 and no naked numbers here. So let's go ahead and put percentages here, atomic mass units, with percent abundance of 48.161 parentheses 7. So if we want to calculate the average atomic mass, we're going to take the mass of each of the naturally occurring isotopes and multiply it by the percent abundance only in decimal form. So we will have 0.51839, we won't worry about the uncertainties here, multiplied by 106.905092 atomic mass units, and 0.48161 multiplied by 108.904756. And when you multiply those by their parts and then add them together, sure enough, we get 107.87 atomic mass units. Let's take a look at the significant digits here. We can see that these have a lot, but each of these percent abundances only have 5, which is why we're keeping 5 in our answer for the atomic mass units for our final answer. And this matches what's in the periodic table, so hopefully this was a good reminder on how to calculate the average atomic mass.